Good morning everyone. So today in this lecture of database management system, today we discuss very important topic, that is normalization. So we need normalization for reducing the redundancy, less chances of data anomalies. So normalization is the process which allows you to win out redundant data within your databases. What is the redundancy? Redundancy means that we have the multiple copies of the same data at the different places. So we have to be, if we want to change the data at one place, so we have to make that changes in all the copies of that data that is stored in the different places. So the normalization is the process which allow to remove the redundancy in your databases. This involves restructuring the tables to successively meet higher forms of normalization. So a proper normalized database have the following characteristics, that it have scalar values in each field. We remove the multi-valued attributes, we remove the composite attributes. We need that in every field we have the scalar values. That we also want that we have the no redundancy in the databases. We use the minimal use of null values and we have minimal loss of information. So for this scalar values and the absence of redundancy, minimal use of null values, minimal loss of information, we need normalization. So the normalization is the process of decomposing unsatisfactory bad relation by breaking up their attributes into smaller relations. Normalization is the process of minimizing redundancy from a relation or a set of relations. So, redundant relation may cause insertion, deletion and updation anomalies, and we have to minimize the redundancy in the relations. We can say that if a same data have stored at the multiple places and if we make some changes at one copy, we have to make that changes in all the copies of that data. And if we have not applying the process of the normalization, then there is a chance of the data anomalies, and these anomalies are of insertion, deletion and updation. So we have applied the normalization with the different form of normal forms. So what is the normal forms? In the normal forms, we have a relation in which certain keys are given to us and the functional dependency of a relation are given to us. And on the basis of these keys and functional dependency of a relation, we have to be certified whether a relation schema is in particular normal forms or not. And we have the different form of normal forms, that is second NF, third NF, BC NF, fourth normal form. We have the different normal forms. These are the labels of normalization. Labels of normalization is based on the amount of the redundancy in the database. The higher the redundancy in the database, the higher label of normalization we have used. So the first label of normalization is the first normal form, second normal form, third normal form, BCNF, that is boycott normal form, fourth normal form, fifth normal form and domain key normal form. So we have the lowest label is the first normal form and the highest label is the domain key normal form. Or the most databases should be in the third normal form or the BCNF in order to avoid the database anomalies. In mostly companies, we have make the data normalized up to the third normal form or the BCNF. So these are the labels of normalization, as we have discussed, that first, second, third, fourth, fifth and AKGEC, that is domain key normal form. Each higher label is a subset of the lower label. We can say that if any relation is in the second normal form, then it should be first in the first normal form, then it should be in the second normal form. For second normal form, we have to be checked that the relation is in first normal form or not. For third normal form, we have to be checked that the relation is in first normal form or not. Then we have to be checked that the relation in second normal form or not. Then we have to come to the third normal form. So each higher label is a subset of the lower label. So first we have discussed the first form of normalization, that is the first normal form. A table is considered to be in first normal form if all the fields contain only scalar values, that we have no multi-valued attributes in the relation. If we have any multi-valued attribute in the relation, then we can say that that relation is not first normal form, and we have to be normalized. We need to be normalized that table, that relation. So for example, this example is given to us in which this table is not in first normal form because author and our author phone number columns are not scalar, because here we have multiple values for author name, that is Sleepy, Snoopy and Grumpy. Same for phone number. For author phone number, we have the multiple phone numbers for the same author. So these attributes have multi-valued values, not the scalar values. So we can say that this given relation is not in first normal form, and we have need to convert this relation schema into the first normal form. So how we convert this relation into first normal form? First, we have placed all items that appear in the repeating group in a new table. For example, we have author name is multi-valued attribute, and this author phone number is also again a multi-valued attribute. From here we have, from the last relation schema, we have seen that. So we have make another table for these attributes that contain the multi-valued. So first we have this table, and we have removing this multi-valued attribute from the base table. So we will get this another table. This is the second table that contain only the multi-valued attribute. So we will then we have designed a primary key for each new table. The primary key of the base table is ISBN, and we add this primary key with this new table. We also add the attribute of the primary key with the new table, and if we have multiple new tables, then in each table we have this primary key. Then duplicate in the new table the primary key of the table from which the repeating group was extracted, or the vice versa. Now on the basis of this primary key, we have scalar values for all the attributes. So now this table is converted from known first normal form to first normal form. Now this table is not in first normal form, but after making a new table, we will convert that relation into the first normal form. The only condition of the first normal form is that it's not allowed the multi-valued values. If we have any multi-valued attribute, then we will make a new table with the primary key of the base table, and we will get that relation into the first normal form. Then we will discuss about the functional dependency. For the higher versions of the normal form, we need to understand the concept of the functional dependencies, because all the normal forms, that is second normal form, third normal form, all are dependent on the functional dependencies. So if one set of attribute in a table determines another set of attribute in the table, then the second set of attribute is said to be functional dependent on the first set of attribute. For example, if x tends to y, it means that y is functionally dependent on x. It means we can derive the values of y on the basis of x. So this is called the functional dependency, that if x tends to y, it means that y is functionally derived from x. This example is given to us. This is the table schema in which we have three attributes, that is ISBN number, title and price, and the functional dependency is given in this relation to us is that title is derived on the basis of ISBN number and price is derived from the ISBN number. We have price is functionally dependent on ISBN, and this title is functionally dependent on ISBN again. So these two functional dependencies are given to us. So functional dependency is one in which one set of attribute in a table determines another set of attribute in the table. This is another example of functional dependencies. This relation is given to us in which we have three attributes, and this functional dependency is given to us that publisher phone number is dependent on publisher ID. Then publisher name is again dependent on publisher ID, and third is given that publisher ID is dependent on publisher name and publisher phone number. These three functional dependencies are given to us. In this, publisher phone number is functionally derived from publisher ID. Another example of the functional dependency, this relation is given to us in which we have again three attributes, and these functional dependencies are given to us. It means that author phone number we have functionally derived from author ID. In second functional dependency, author name we have functionally derived from author ID, And in author ID, we have functionally derived from this key, that is author name and author phone number. This is composite key, in which we have two attributes. So we can say that author ID is functionally derived from both these two attributes. Then we have discussed about the different types of functional dependencies. We have two types of functional dependencies. One is the trivial functional dependency and second is the non-trivial functional dependency. If A tends to B has trivial functional dependency if B is a subset of A. If B is a subset of A, then we can say that A tends to B has trivial functional dependency. And this also known as trivial functional dependency if A tends to A and B tends to B, because if A tends to A, it means again A is a subset of this A. So these are the cases of trivial functional dependency. We see another example of trivial functional dependency. Consider a table with two columns that we have these two columns. We have a table of employee. In which we have these two attributes, employee ID and employee name. We have this table employee. In this we have employee ID and employee name. So in this we can say that this employee ID, we see this functional dependency. We can say that this functional dependency is trivial because this functional dependency is given to us that employee ID is functionally determined from employee ID and employee name. And this employee ID, we can say that if A tends to B and B is a subset of A, then it is trivial functional dependency. And here employee ID is a subset of this A. This is B here and this is A here. This both two attributes make A here. And B is a subset of A. Then we can say that this is a functional dependency. This is a trivial functional dependency. Then this is non-trivial functional dependency. If B is not a subset of A, then that is called the non-trivial functional dependency. And also A intersection B is null. If we have two attributes, that is A and B, and the intersection of A and B is null, then we can say that A tends to B is called as complete non-trivial functional dependency. For example, this name is functionally derived from ID and date of birth is functionally derived from name. If we make the intersection of A and B, we will get null here. So this functional dependency is called the non-trivial functional dependency. Here, if ID tends to name, if this implies A and this implies B, and here B is not a subset of A, then that is non-trivial. And in this case also date of birth is not a subset of this A, then again this is non-trivial. And if we have make the intersection of A and B, that is ID and name, we will get null because there is nothing common in this A and B. Then this is called the complete non-trivial functional dependency. So functional dependency is that in which if we can say that if A tends to B, then we can say that B is determined from A, or we can say that B is functionally dependent on A. And on the basis of this functional dependencies, on the basis of this keys given to us, on the basis of that we have normalized the data. So functional dependency is an important concept in the terms of the normalization or in the terms of the normal forms. So the higher versions of normal forms like second normal form, third normal form, in all the cases we have used the concept of the functional dependencies. We can say that the problem of the normalization is the redundancy. We can use the normalization for removing the redundancy, because if we have redundant data, then we have the anomalies in the database. Anomalies means that we have some sort of redundant data in the databases. If there is redundancy, then there is anomalies in the database. So that's why for removing the redundancy or for removing the anomalies, we have using the normalization. So what type of anomalies chances have to be occur in the databases if we have redundant data? So here we have discussed the types of the anomalies that should be occur if we have the redundant data. So there are three types of anomalies that occur when the database is not normalized. So what are these three types of anomalies? These are insertion anomalies, updation and the deletion anomalies. We will understand this with an example. This example is given to us. In this, we have this attributes, employee ID, employee name, employee address, and employee department. The values of this is given to us. This data is not normalized. We'll see the problem that we have. This table is not normalized because for the same name, that is Nick, we have 2 departments. So this data is not normalized. So on the basis of this table, we have 3 types of anomalies. First is the update anomalies. We can say that we have 2 rows for employee. We have 2 rows for employee. Here, Rick, and he belongs to 2 different departments of the company. If we want to update the address of Rick, then we have to update the same in the 2 rows, or the data will become inconsistent if we have only change at the one place. So the corrected address get updated in one department, but if that not updated in the other department also, then the database become inconsistent. So this type of anomalies, this type of updation anomalies may be occur if we have the redundant data, or we can say that if we have not applying the normalization. We can say that we have Rick, and for Rick we have the 2 different departments, and if we want to change the address of the Rick, and if we make that change only at the one place in the one department only, and we not make that change in the other department also, then the database become redundant. And for removing this type of redundancy, we have to make the data normalized. Then second, we have insertion anomalies. Suppose we have a new employee coming in the company, a new employee join the company. Still, that employee is on training period and currently not assigned to any department. Then we are not able to insert the data into the table in the employee department field because we don't allow the null values in that. Because that for adding that employee, we have need to be the department name also, because we don't allow the null values here. So we have the insertion anomalies if we have the redundant data or we have not applying the normalization there. Then third type of anomalies is the deletion anomalies. Suppose if at a point of the time the company closes the department this D890 and we have only one employee in that department, then deleting the rows that are having employee department 890 would be delete the information of the employee also, since for this employment, for this department we have not assigned any employee. If we want to delete this department, that 890, then we delete all the information also related, all the employees that related to this D890. So on deleting the attribute, on deleting the particular attribute, particular department, we also deleting the data of the employee also. So if we have not using the normalization, then we can say that we have redundant data into the database, and for that redundant is arise because of these type of anomalies into the database, that is update, insert and delete anomalies. Then we come up to the second normal form, that is based on the functional dependencies, and we already know that for a relation to be in second normal form, first that relation to be in the first normal form. So before checking any relation into the second normal form, first we check that relation is already into the first normal form or not. If that relation is not in the first normal form, then we first convert that relation into the first normal form, then we come to the second normal form. So for a table to be in second normal form, there are 2 requirements. First, the database is in the first normal form. Second requirement is that only known key attributes in the table must be functionally dependent on the primary key. For example, what are the known prime attributes? First, we discussed about the non-prime attributes. For example, this relation is given to us in which we have, this is the table of the employee, in which we have employee ID, employee name, employee salary, employee department, employee address. This information is given to us. We will check that this relation is in second normal form or not. In this table, the primary key is given to us is this. In this table, the primary key is given to us, that is the composite primary key, in which we have 2 attributes, that is candidate key, that is employee ID and employee name. And some functional dependencies also given to us. So What are the prime attributes? The attributes that are the part of the primary key are called the prime attributes, and the attributes that are not part of the primary key are called the non-prime attributes. So these are the non-prime attributes, and this employee ID and employee name are the prime attributes. So this second normal form is dependent on the non-prime attributes. We can say that the non-prime attributes are fully functional, dependent on the entire primary key. We can say that the primary key of this table is employee ID and employee name. If we can say that this employee salary is dependent on this employee ID, this employee salary is functionally dependent on employee ID and employee name, then we can say that this relation is in second normal form. But if I write here that employee salary is only dependent on employee ID, then this is not in second normal form, because this is partial dependency. This is not fully functional dependency. We can say that if a key is made up of composite attributes, it is made up of composite attributes, means that primary key not have only one attribute. Instead, this have two attributes, that is employee ID and employee name. Then this e-salary is dependent on both that employee ID and employee name. If this employee salary is only dependent on either employee ID or either on employee name, then we can say that that relation is not in second normal form, because there is partial dependency exist here. And if partial dependencies exist any relation, then we can say that that relation is not in second normal form. We take an example here. This schema is given to us in which we have these attributes, that is title, publisher ID, author ID, price and author address. These attributes are given to us, and in this the key, the candidate key is title, publisher ID and author ID. This is the primary key is given to us, and this functional dependencies are given to us. The price is fully functionally dependent on title, publisher ID and this. See this is functional dependent. This is in second normal form. This functional dependency in second normal form. Why? Because this price is fully functionally dependent on title, publisher ID and author ID. And this relation, this functional dependency, third functional dependency is not in second normal form. Why? Because this author address is partially dependent on author ID, because our primary key is title, publisher ID and author ID. If this author address is dependent on title, publisher ID and author ID, then we can say that this functional dependency is in second normal form. But in this case, this relation is not in second normal form, because this is partially dependent on the author address. So the author address does not belong to a key, and author address is functionally dependent on author ID, which is a subset of key. So in second normal form, we have to be checked for the partial dependency and for the functional dependency. If any functional dependency is fully functionally dependent on the primary key, then we can say that the relation is in second normal form. Otherwise, we have to convert that relation into the second normal form. This is another example of the second normal form. This relation is given to us in which our primary key is city, street and house number. This first, we will check for this functional dependency, that is in second normal form or not. Our primary key is city, street and house number, and this house color is dependent on this primary key. And this primary key, this relation is fully functional, because we have this house color is dependent on city, street and house number, that is the primary key of this key. So we can say that this is fully functionally dependent. So this relation, this functional dependency is in second normal form. Then we check for this functional dependency, that this is in second normal form or not. That city pollution is only dependent on city. That is the part, city is a part of a primary key. City is not a complete key. City is only a subset of, only a part of this key. So we can say that this relation, this functional dependency is not fully dependent. This functional dependency is partial. In this case, this relation is not in second normal form. There is another example to check for the second normal form. This relation is given to us. In this is given to us as a key. We will check for this relation, that budget. Budget is fully functional dependent on studio and movie, then this is in second normal form. This studio city is only dependent on a part of key. So this is not in second normal form, because this is partial relation. then we have this, we can say that this is studio city is not a part of the key. So studio city functionally dependent on studio, which is not a proper subset of the key. So this is in second normal form and this is not in second normal form. Now we have to be, if the relation is not in second normal form, then we have to be convert that relation into the second normal form. So now the decomposition, that if any relation schema, it is not in second normal form, then how we convert that relation into the second normal form. So if the data item is fully functional dependent on only a part of the primary key, then move that data item into the part of the primary key to a new table. If any relation schema is not in second normal form, for example, this functional dependency in second normal form, but this functional dependency not in second normal form. So how we convert this? We will make the relation that is not in fully functional dependent, then we make a new table for this relation. So how we convert? We have this base table, then we will make a table that is studio, movie, budget and studio city. And we will make another table that contains studio and studio city. And we'll make this as a primary key of this table. So in this way, we have decomposed. If a relation is not in second normal form, then we convert that relation into second normal form by making a new table. For example, this is our old schema, and we see that this relation is not in second normal form. Then we'll make a new table for this relation, and we'll make again a new table for this relation. So in this way, we have decomposed if any relation not in second normal form. Thank you. In next lecture, we have discussed about the third normal forms and the higher versions of the normal form. Thank you for the day.